Hi, I'm James, and today we're going to walk through the Axiom 2x2 CNC. When you purchase your Axiom 2x2 CNC, it will arrive in packaging similar to this. Excited to open it up and show you what's inside. Okay, now we're ready to lift the machine from the box. This is a two-man lift. You'll need some help. Now that the CNC is out of the box, we're going to walk through everything that's included. Here we have the Ethernet cable used to connect your CNC to your PC. We have the power cable for your CNC. We have the leveling feet for your CNC. We have the thumb drive with your UC CNC software and installation instructions. We have spanner wrenches for your collet nut. We have an 1/8 inch collet. The 1/4 inch collet is installed in the spindle. We have our touch-off puck. We have 4 screws for mounting the Z-axis and spindle. And we have Vectric desktop software. Now that we've reviewed the contents of the box, let's assemble the machine. First, we'll want to install the leveling feet. A 14mm wrench is used for this step. Now we're going to mount the Z-axis to the gantry. You'll need to locate the 2 holes at the top of this plate and the 2 holes at the bottom of this plate. We'll feed the bolts from the back into the insert nuts in the Z-axis. For this, you'll need the mounting hardware and a 4mm hex key. It's helpful to use the top 2 screws to stabilize the Z-axis before installing the bottom screws. When installing the lower screws, you'll want to install loosely, then level the top of the black plate with the bottom of the bracket to set your Z height. Now that we've unboxed and assembled the machine, let's discuss the power requirements. This machine runs on a 115 single-phase power, and we recommend a 15-amp circuit. Now that we're ready to run the machine, let's power it on and review some of the basic UC CNC controls. When starting a project, you'll need to install a bit. On complex projects, you may need to change bits once or more times. When installing a bit, first place the software into a safe position by clicking the reset button. Remove the collet nut. Insert your bit. Replace the collet nut with bit inserted onto the spindle, and tighten the collet nut using the supplied wrenches. Before we can run a project, we'll first need to establish the X, Y, and Z work origins. To establish the X and Y, you'll use the jog controls to move the spindle to your desired position. You'll then use the X and Y zero to zero that marker. We'll then use the touch-off puck either on top of the workpiece or on top of the table, depending on how you have it set up in your program, to establish the Z work origin using the probing button. Oftentimes, you'll need to move the spindle to a desired position. In order to do so, you'll hover over the jog controls. You'll use Y plus and Y minus to move the machine forward and back. You'll use the X plus and X minus controls to move the spindle left and right. And you'll use the Z plus and Z minus controls to move the spindle up and down. To change movement speeds up or down, you can use the plus or minus jog feed controls in 10% increments. For even smaller movements, you can put the machine into step mode and then select the increment 1mm, 0.1mm, 0.01mm, or 0.001mm movements. In step mode, X, Y, and Z buttons will move in the selected increment. Our machine comes with collets for use with 1/4 inch and 1/8 inch bits. To change from the included 1/4 inch collet to 1/8 inch collet, you'll press the collet slightly to the side until the inner ring snaps loose, and then remove the collet. You'll replace with the 1/8 inch collet, ensuring you hear that snap when it engages. When you're ready to run your project, you can load your project file from either the thumb drive or from the computer itself. Once you've installed your USB drive, locate Load File, navigate to the drive, select your program file, click Open. You'll now see a preview of your toolpath. Now that we've loaded the toolpath and set our work origin, we're going to simulate running that toolpath. To start running the toolpath, we'll hit the Cycle Start button. The feed speed and spindle speed can be adjusted using the F+ and minus and S+ and minus buttons on the display. If you need to stop the machine anytime while it's running, you can press the Cycle Stop button. You can resume from that same point by pressing the Run From Here button and then Cycle Start. You'll receive a pop-up window where you can confirm the program settings. Once confirmed, you'll press the Cycle Start button again. This allows you to resume cutting without having to restart the entire program. There are a variety of bits available on the market. Today we're going to talk about a few of the most common and some of their uses. First, we'll discuss a straight end mill. This is a flat bottom cutter that's used for straight down cuts and across. Common uses are shapes and pockets with flat bottoms. Straight end mills come in two varieties, upcut and downcut. The upcut bits are used for through cuts where you require a clean bottom edge. Downcut are for pocketing cuts where the top edge needs to be clean. Up next is the V-bit. As the name implies, this bit is V-shaped and cuts thin, angled lines. Common uses are engraving and decorative lettering. Up next is the ball nose bit. This bit has a rounded end and cuts smooth, curved surfaces. This bit is commonly used for 3D carving. Up next is the tapered ball nose bit. This is a detailed version of the ball nose bit that comes to a fine point. This bit is used for detailed 3D carving and tight corners. On a daily basis before operating the machine, check and remove any dirt and debris. Do not operate the machine if anything is loose or damaged. Each axis is equipped with a prismatic linear guide and ball screw. Each of these has a grease fitting. For detailed instructions on how to lubricate each of these, refer to Section 12 of the user manual. At the rear of the machine, there's a screen that will display error codes in the event of a fault state. You can refer to Section 13 of the user manual for error codes and detailed troubleshooting information. When you first receive your Axiom 2x2 CNC, before you run any other programs, it's recommended to surface your spoil board. When surfacing your spoil board, you'll use the table surface as your reference point with the touch-off puck. A surfacing toolpath will need to be created and executed to surface your spoil board. Surfacing your spoil board will ensure that your cutter head and work surface are parallel. This will ensure precision while machining. Periodically, your cutter head will cut through your work material and into the table surface. In these instances, you'll need to resurface your spoil board.